I am R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we will discuss the topic on reflector antennas. So, reflector antennas, an antenna reflector is a device that reflects electromagnetic waves. Antenna reflectors can exist as a standalone device for redirecting radio frequency energy, or it can be integrated as a part of antenna assembly. The function of standalone reflector is to direct electromagnetic energy generally in the radio wavelength range of the electromagnetic spectrum. Reflector antennas are widely used to modify the radiation pattern of the radiating element, increasing gain in a given direction. So there are different types of reflectors are available. For example, large sheet reflector, small sheet reflector, thin reflector, active corner reflector, passive corner reflector, parabolic reflector, elliptical reflector, hyperbola reflector, and circular reflector. So in today's topic and in this video, we will discuss about the parabolic reflector. It is the microwave antenna. The most well-known reflector antenna is the parabolic reflector antenna, commonly used as satellite dish antenna. And these antennas are widely used for radio and wireless applications. And parabolic reflectors typically have a very high gain, 30 to 40 decibels, and they have a reasonable bandwidth, can be used a very wide bandwidth, and also in the case of huge dishes. The small dish antennas typically operate between 2 to 28 GHz. The large dishes can operate in the very high frequency region 30 to 300 MHz, but typically need to be extremely large at this operating point. So this is the diagram of a parabolic reflector antenna. The parabolic reflector antenna, we have a main reflector, a parabola. At its feed position or at this focal point, we have another antenna. So it is exactly located at its vertex. And this is the geometry of a parabolic reflector. A parabola with O dash is the axis, and the width is d, and here P is the point and F is the focal point. So F is the focal point, V is the vertex, and the line joining the vertex and the focus point is the axis of symmetry. PQ are the reflected rays, where L represents the line directrix on which our reflected points lie. And hence, as per the above definition, the distance between F and L lie constant with respect to the waves being focused. The reflected wave forms a collimated wavefront out of parabolic shape. The ratio of focal length to aperture size F by D is known as F over D ratio, and it is an important parameter of parabolic reflector. Its value varies from 0.25 to 0.5. So the law of reflection states that the angle of incidence and the angle of reflection are equal. This law, when used along with the parabola, helps the beam focus. The shape of the parabola, when used for the purpose of reflection of waves, exhibits some properties of the parabola which are helpful for building an antenna using the waves reflected. All the waves originating from focus reflects back to the parabolic axis. Hence, all the waves reaching the aperture are in phase. As the waves are in phase, the beam of radiation along the parabolic axis will be strong and concentrated. So, following these points, the parabolic reflectors help in producing high directivity with narrower beamwidth. So, the construction and working of parabolic reflector. So, if a parabolic reflector antenna is used for transmitting a signal, the signal from the feed comes out of a dipole or horn antenna to focus the wave onto the parabola. It means that the waves come out of the focal point and strike the parabolic reflector. This wave now gets reflected as collimated wavefront, as discussed previously, to get transmitted. So parabola is a two-dimensional plane curve. Parabolic reflector or paraboloid is a three-dimensional curved surface. It produces a parallel beam of circular cross-section because the aperture of a paraboloid is circular. Radiation pattern has a very sharp major lobe and minor lobes which are smaller in size. So the diagram represents the radiation pattern of a paraboloid. And the two important parameters are spillover and backflow. So it means that some desired rays are not captured in the reflector antenna, and this is called spillover. And spillover increases noise pickup, which is troublesome in satellite ground stations. So to avoid this spillover, we use different feed systems: dipole feed, horn feed, end-fire feed, Cassegrain feed. So advantages, we have reduction of minor lobe, wastage of power is reduced, equivalent focal length is achieved, feed can be placed at any location, and adjustment of beam is possible. Disadvantages, some of the power that gets reflected from parabolic reflectors is obstructed. This becomes a problem with small dimension parabola. Assessment, which of the following wave conversion mechanism is performed in a parabolic reflector antenna? It is spherical to plane. And which of the following is a dual reflector antenna? We know it is a Cassegrain antenna. Thank you.